Okay, so hello everyone. Hello everyone. So welcome to our today's webinar on blockchain. I'm Simran Bhardwaj, core team member of DSC JIIT 128. Okay, so guys, if you don't know about BitBox, so it's a solution challenge hackathon. So do register for it. The link is given in the description. Okay, so moving on with our webinar, I would like to welcome the speaker of our today's webinar, Mr. Akhil Bharati. So he's senior software engineer at Tezos India. He's a blockchain developer with more than 2 years of experience. He's been building crypto wallets and writing smart contracts on various blockchain based platforms. He's also interested in building a decentralized financial ecosystem. Okay, Akhil, so it would be great if you could enlighten us with what is blockchain and how to be good at it, and what are the best resources to learn from about it. Okay, so the stage is all yours.
Thanks, Imran. Uh, cool. Just give me a minute. I will set everything up and we will get started. Hi, everyone. So let's get started with today's session. So today we will be talking about a brief overview of the whole blockchain space. Then I will go over why Tezos is a different platform uh, and why it stands out. Then we will dive deep into the architecture of Tezos, and then we will see like how we can get started with developing on it. Okay, so what is blockchain? So at the core, it's just a ledger, and people are trying to trade or willing to trade goods or services for a higher number in that ledger, and that and you believe that everyone else will also do the same. So that is why we can like think of blockchain as like a ledger which can store anything of value. That can be like money, but we will see like that can be other things as well, such as digital assets and so on. Okay, so what happens like when you do a transaction in a centralized network? So say if you want to say send a person some amount, then you just like go to your bank app or centralized processing like system such as ATM or anything else, and then you do that transaction, and that actually goes to a central clearing house, which is the central bank server, which tracks your balances and everything, and once everything checks out, it approves your withdrawal, or it approves your transfer. But in case of Bitcoin, it's different. So say if you have four participants in the network, then what will happen is if you do a transaction, then you share that copy with everyone, and at the end of the day everyone is aware about every transaction. So there is no discrepancy as such, who owns what amount. So if anyone can and this network is also open, so anyone, any new participant can also come here and join the network from scratch. Like he will get a list of all the transactions and of whatever has happened in the past, so that he can track balances of uh, uh, all other peers. So but how will since like these transactions happen over a network, how can we say that this transaction is originating from the right person? So we use digital signatures for that. So basically in digital signatures you have two parts. There is one public part and there is one private part. And public part is something like your a username, but not like quite like it. And private key is your password. So basically what happens is, if you want to do a transaction, then you sign it using your private key, and then you broadcast it to the network along with your public key, so that anyone else can verify that okay, this particular transaction is originating from the person who holds this particular private key. So and this private key is like nothing but a randomly generated number. So in case of a Bitcoin, it's a 32 byte long string, and uh, public key is derived from that random number. So there are different algorithms of derivation, and that is where the difference comes in. So for example, Bitcoin uses a elliptic curve cryptography, whereas there are some blockchains which use Edwards cryptography as well. So also since this private key is responsible for all your ownership of the transaction, or like basically all your funds, any loss in private key ultimately means you are losing all your funds. Next thing is, if Uh, so since the network is are delayed sometimes, and it may happens that some transaction arrives later than it happens, and there is misordering of transaction, then how do all the nodes come to a consensus that this is the correct order of transaction? So for that, in Bitcoin, we have an algorithm called proof of work that allows us to reach that consensus. In Tezos, we have liquid proof of stake. We will like learn about liquid proof of stake later in this session. Uh, so let's understand like how the at ordering actually works. So what happens is, you have a whenever you do a transaction uh, that is ultimately waiting to be get approved, or rather validated by the network, or let's just say that confirmed by the network. So transaction is only confirmed when it's part of a block. So many transactions come together to form a block, and a block is mined in Bitcoin every 10 minutes. So and there is also a specific reason to why it's 10 minutes. But the main thing is, when you want to do a uh, or rather, when you want to order a transaction, you basically look at the block number. And for ordering the blocks, what we do is we hash that block, and we use that hash of the block in the next block's hash. So let's just first understand like what is a hash. So hash is just a one way function. So any data returns the same hash, but never two different data will return the same hash, and it's not possible to get the data back from that hash. So these are some of the properties of a hash function. So uh, or a hashing function. And this allows hashing to be used as a check of consistency basically. Uh, so whenever there is a change in data, there is a significant change in hash, and the resultant hash is like entirely different. So let's just now see like how this property can help us to order the transactions. So we hash a particular block, and then we use that hash in the next block's hash. So it kind of gets confirmed that whatever the block was before this, that had this particular hash. So there can be no confusion that which block came before this. Now let's just see like how those transactions are actually get confirmed. So what happens is, once you do or you broadcast the transaction, it will ultimately reach to a mining node, which is nothing but a person running the entire node, or the full node. So full nodes are huge, and usually you require a dedicated setup to run them. So what will happen is, when this not centralized, this full node will receive the transaction, then it will try to uh, guess the hash for it. And guess in the sense, there is a particular condition to become part or become the next block, and that condition is called the difficulty condition. So what you can do is, hash is a long 64 byte long string. So what you can do is, you can constrain first 8 bytes and say that, okay, first 8 byte needs to be 0. So what will happen is, coming up with a hash that has that particular condition is difficult. So what this node or this full node will try to do is add some random number to this block, and try to satisfy that difficulty condition. And that random number is called nonce, or the block nonce. And ultimately, when it guesses that correct block nonce, it satisfies that difficulty condition, and ultimately that transaction is or he broadcasts that hash to other nodes, and they can check that, okay, this hash satisfies the condition, and this particular address found it. So he will get the transaction fees, whatever is involved with the whatever was involved with all the transactions in that particular block. So now the question is, why blockchain? So since all the transactions are available for anyone to read at any point of time, blockchain is very transparent. There is no central authority or middleman. So in case of like even in case of money transfer, you can't really transfer someone money without involvement of Reserve Bank of India, because if even if you are paying someone cash, it's just a promise to pay that particular amount of money by RBI. So RBI is actually the middleman in this case, who is helping us do that transaction. But in case of blockchain, there is no middleman. You can like transfer money as well as other digital assets without the need of a middleman. So third is open participation. So anyone can join the network from anywhere. He just needs uh, internet connection. And sometimes you will see that it's not even like internet connection isn't even required to participate in blockchain transactions. And since we have a record, ordering of all our records, all our past records, so and no one can change it without being able to like guess all the previous hashes. So it's and that is pretty difficult, so we can say that blockchain is immutable. And the last one is and this is actually a pretty important thing, that no trust is actually required to perform a transaction on the blockchain. You can take a loan from anyone, and uh, uh, actually that person doesn't even have to know your details. So such a system can be created using blockchain. Karan Tejwani wants to know what the block reward. So it's the s- so currently like reward is fixed for whoever mines the transaction. And in this case, whoever was finding that particular hash gets that block reward plus all the transaction fees for the transactions in that block. Anyone has any more questions? Cool. So, what is Tezos? So, Tezos is also a blockchain platform, and what's different from other platforms is it uh, it has a self governance system, and also it's pretty scalable. So, why do we need an on-chain governance? So, what happened in case of uh, 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 I guess like 3 or 4 years back, there was a case of DAO hack, wherein in the Ethereum network, a DAO wallet was hacked, and a large amount of a large amount was withdrawn from that particular account. And then there was a meeting among the Ethereum community. Since the amount was so big, they said that like they wanted to revert that transaction back. And since it's like really not uh, since it's like really not possible to change back data, all like users in the network would have to upgrade their wallets in order to like accept that reverted transaction. So uh, but there was a group of people who said that like this is against the ethics of the community, and like ethics of the blockchain itself, and they didn't want to, and ultimately they didn't revert that transaction, and that fork is known as Ethereum Classic. And the uh, the fork which accepted that reverted transaction is the Ethereum as we know it. So such a case doesn't occur in to make sure such a case never occur in Tezos, there is a on-chain governance protocol. So any updates in the network has to be approved by people in the network itself, and which are like usually bakers. So, and what it does is like how it happens is, say a new change is proposed, and there is some person developing that proposal, and he ultimately submits that proposal along with the links of code and everything. And what will happen is, if everyone approves that proposal, the network will automatically uh, download or update its protocol on the basis of uh, like whatever the proposal contract or code was. And whoever was the person developing that proposal also gets paid automatically. So this on-chain governance allows Tezos to avoid like major hard forks. So Tezos nodes use a consensus mechanism called liquid proof of stake. So let's just understand what is proof of stake. So it basically says that whoever a person can stake some amount of Ethereum which he has to approve some transactions. Which this is basically saying that anyone with more number of uh, Tezos actually has more chances of validating a transaction, because in a real sense he actually has more stake in it. And if anything goes wrong, like he will be the one actually losing money. So this kind of actually works, and this is not like truly decentralized. So Tezos came up with liquid proof of stake, wherein you have bakers. Bakers are the people who are actually validating, and people stake their Tezos to bakers. So anyone in the Tezos network can stake some Tezos to any baker of their choice and get involved in the transaction validation process, and in turn get the block reward, and also the transaction fees that comes along with that block. So how does Tezos actually work? So let's just see how we interact with it. So we use this RPC to actually do all kind of interactions with our main network, and you will find most of the times interacting using a client. So this can be done using our libraries, and to basically push any transactions or retrieve any transaction data. And then we have our explorer. So this guides, or this is a history of all the transactions uh, in the network, and you can explore them, you can explore the accounts as well. And all of this like eventually fetches its data from the RPC, which is a remote procedure uh, calls. So at the inside the network, we can see that we have a protocol layer, and then we have validator, and then we have a standard P2P interface. So this is pretty standard. This is the same thing which runs in the torrent, and in the back of torrent. Then we have the central protocol, and then we have the compiler which the protocol uses, and these things can be updated. So whenever actually this protocol is the part which gets updated in case of on-chain governance. So what are smart contracts? So blockchains, apart from doing monetary transactions, can also be used for doing other financial transactions, such as transferring of digital assets, doing building a micro loaning service, or doing exchanges of assets or even currencies. So smart contracts allows us to do that, and they are just like a code running on the network itself. You can think of entire Tezos blockchain as a huge computer which is running this particular code, which is the smart contract. So this allows us to build like very like automated applications, such as uh, for example, you want to hire a freelancer to do a job. So and you want you have set some milestones. Okay, so this is the milestone 1 2 3, and you have written test cases for those milestones, and you have written a smart contract. Okay, so when the first set of test cases pass, transfer this much amount to the freelancer, and so on for the rest of the test cases as well. So such systems can be built using smart contracts. uh, we can also have escrow smart contracts, which is nothing but so say two parties are doing a transfer, and you want to make sure that no one loses their so one party has the asset and one party has the monetary value, or say the cryptocurrency to buy it. And we don't want either parties to lose their valuables. So escrow is basically that person will transfer his digital asset to a smart contract, and the other person will smart transfer his money. And when everything checks out, the swap will take place, and they will get back the asset in place of the money. So how do we write smart contracts on Tezos? So we have SmartPy. It's a Python library. Uh, it helps to generate Michelson code from Python, and Michelson is ultimately used in Tezos VM, and uh, yeah, that's about it for SmartPy. So these are some of the tools that you can use for development. Taster is your local development setup. It has a local node. You have a editor as well as a explorer built in with the GUI. Uh, yeah, that's it from my side. If anyone has any questions. Cool.
Thank you so much, Akhil. It was so informative. I hope our audience got to know a lot of things about blockchain. So thank you so much. And thank you very much to our audience too. Also, do register for BitBox. The link is given in the description. So I told you it's a solution challenge hackathon. So do register for it. So thank you very much. Till then, bye bye.